Let's look at the following example. Suppose XYZ company yesterday paid a dividend of 50 cents per share to each of its stockholders. It is expected to increase its dividend by 2% per year. The market requires a return of 15% on assets of this risk. Question number 1. How much would new investors be paying for XYZ stock today? Question 2. What will the stock be worth in 5 years? So you need to find P0 and P5. Price in year 0 and price in year 5, right? So a 50 cent per share dividend has just been paid, and it will be growing by 2% every year indefinitely, right? It doesn't specify when that growth would end, so you should assume it will never end. That's how you know it's a perpetuity, and it's a growing perpetuity. Okay, so let's answer the first question first. How much would new investors be paying for XYZ stock today? We know that the dividend that has just been paid is 50 cents, right? It is given. To find the stock price today, we need to use dividend in 1 year in the numerator and divide it by R minus G, right? That's the present value of a growing perpetuity formula. So what will the dividend be in 1 year? It's the dividend today increased by 2%, right? So D0 multiplied by, open parenthesis, 1 plus G, close parenthesis. Applying the numbers that were given to us, we have 50 cents times, open parenthesis, 1 plus 0.02, close parenthesis. That gives us 51 cents. You can also do this in the financial calculator, right? Let me bring it up. And actually, let me move it here. So let's turn the calculator on. Let's start by clearing everything. Second, plus, minus, enter. That's because sometimes when you're doing new calculations, you're not realizing that the calculator uses some stored information, and that completely messes up your result. So we know the dividend today, that's the present value, 50 cents, 0.5, make it negative, plus minus key, save as present value, press the PV button. We want to find the dividend in 1 year, so 1N. And the dividend will increase by 2%. That's our rate of increase, 2IY. And finally, compute FV, the future value, 51 cents, right? And then once you're done with finding the next year's dividend, you can then divide it by R minus G. This is the present value of a growing perpetuity formula that must be used to find the stock price today. Plugging in the numbers, you get 51 cents divided by 0.15 minus 0.02, which gives $3.92. Okay, so if you pay $3.92 to buy 1 share of stock, that will pay you 51 cents in 1 year, and then increase in dividends in the future at the increase rate of 2%, then this is the right price. You will get your money's worth. If the share costs more than $3.92, it's not worth buying it, because you would be paying more than the amount of money you would be getting back in future dividends. Okay, so now let's move to the second question in this problem. What will the stock be worth in 5 years? So think about a very simple transition from question 1 to question 2. We basically take all the calculations that we have, and we need to shift them by 5 years into the future. So if you look at what we did as the last step to find today's price, we had to use year 1 dividend over R minus G. Now, to find the price in 5 years, we need to do the same thing. We go one step further. So dividend in 6 years should be divided by R minus G. Okay? How would we find dividend in 6 years? We can, for example, take the most recently paid dividend, 50 cents, which was given, and multiply it by 1 plus the growth rate, which is 2%, and raise to the power 6, right? And you can also do it in the financial calculator, this sort of the first step in the second question. Again, let's clear everything just in case and start all over. 50 cents, 0.5 negative is our present value. In 6 years, so I press 6N. At 2% annual growth, I press 2IY. What will be the dividend? Compute FV. 56 cents. On the screen it's rounded to 2 decimal places. On my slide I have 56.3 cents. So it's always better to increase the decimals. I actually didn't do that, but I probably should have. And then after completing this first step, you can do the second step to find the price in 5 years. To find the price in 5 years. Dividend in year 6 divided by R minus G. So notice how this is exactly the same formula that we used in the first question. So to find price 0, we need dividend 1. To find price 5, we need dividend 6, right? Plugging in the numbers, we have 0.563 of a dollar divided by the difference between 0.15 and 0.02, which gives $4.33. Okay? Let me show you one more interesting result. By the way, notice how today's price is lower than the price in 5 years. Is it always going to be the case? Actually, yes. But before I summarize that result, let me show you something interesting in the financial calculator. Let me clear everything. And what I want to do is, now that I know that today's price is $3.92 and the price in 5 years is $4.33, and that they are 5 years apart from each other, what is the implied annual increase in the stock price? Let's calculate that. So I have 3.92 negative, that's my present value. I pressed PV. $4.33 is the future value. 4.33, I keep the sign positive and I press FV. I know that the two prices are for the same share of stock, and they're 5 years apart. So that's my N, 5N. And let's compute the implied annual increase in the stock price. Compute IY. 2%. I actually have 2.01. It's a rounding error because I have rounded price 0, rounded price 5 used in my calculation. If I kept more numbers after the decimal place for price 0 and price 5, then on my display I would see 2.00, exactly 2% per year. Is it a coincidence that the price increases at 2% just like the dividends? No, it's actually always going to be the case. So bottom line, in the constant growth dividend case, whatever the annual growth rate in the dividend amount is, that will also be the growth rate in the stock price. So another way I could do the calculations to the second problem was, what I could also do is I could take my price today, so 3.92 negative PV, and then say that after 5 years, 5N, at 2% growth in price, 2IY, what would be my stock price in 5 years? Compute FV, $4.33. Just like the answer we got when we followed a completely different calculation approach, right? Okay, so actually mathematically it can be proven that this will be always the case. To find the dividend in 5 years, for example, we take the dividend today and multiply by 1 plus the growth rate in dividends, G, to the 5th power. To find the price in 5 years, we need to take the dividend in 6 years, right? Always one extra here, over R minus G. Now, what is the dividend in 6 years? We can say that it's the dividend in 1 year multiplied by 1 plus G to the 5th power. And then we can realize that dividend in 1 year divided by R minus G is the same thing as the price today. So what we get is dividend in 5 years is today's dividend times 1 plus G to the 5th. And the price in 5 years is the same thing. It's price today times 1 plus G to the 5th. So this is how mathematically, if this all made sense, you can actually prove that the price will also be growing at the same annual rate as to the dividends. But bottom line is the price grows at the same rate as dividends in the constant growth dividend case. You don't really need to be able to prove it all mathematically. And one last note about the constant growth dividend formula. This formula only makes sense when the discount rate R is greater than the growth rate in dividends G. It is the only case when the formula works. What happens if it's the other way around? If the discount rate is less than the growth rate, then in the denominator, R minus G becomes negative, right? Which will make the whole price negative, which doesn't make sense. Instead, the right way to think about what the price would be if the dividends grow at a faster rate than they get discounted. The right way to say is that if dividends grow too fast, the price will be infinitely large. So actually, there would never be a negative price, even though the formula would make it look like it. The price will be infinitely large.